In this video, we're going to look at 3 different ways that we can write an equation of a line. So as we've gone through writing equations, we've looked at our slope-intercept or our function form, which is that format where y is equal to mx plus b. Basically, we can see that it's in slope-intercept form when our y is by itself, and then we have the x on the other side and possibly some number added on at the end. The coefficient of x is our value for slope. We represent that with m. And the value for b is the y-coordinate of our y-intercept. And again, we usually write that as an ordered pair 0, comma b. Another form of a linear equation that we've worked on in this unit is our standard form. And when we talked about standard form, we looked at finding the x and the y-intercepts and then drawing our graph. But the important thing to remember about standard form is that a, b, and c are all integers, which means there's no fractions. They're all just whole numbers. And a always has to be a positive integer. So the value for a should always lead off with a positive value for x. We can recognize standard form when our x's and y's are together on the same side of our equal sign. And then our newest equation of a line is what we call a point-slope form. And the point-slope form is called the point-slope form because we use the coordinates of a point, which are represented in here by the x1 and the y1. So those are representing my point. And the value for m is still my slope as it's been in the slope-intercept and our point-slope form. All 3 of these equations are different ways to represent lines. And we're going to look at how we can write 3 representations for the same line using these different formats. We're going to start out by reviewing the most basic way that we can write an equation of a line. If we have a graph, then we can focus in on our slope-intercept form as long as we can see where our graph is crossing the y-axis. So wherever my graph crosses the y-axis, that's my y-intercept. And if I look at my y-intercept, in this case, it's the ordered pair 0, 5. When I know my y-intercept, the y-coordinate is going to be my value for b in my slope-intercept form. So I can now say that b is 5. In order to write the equation in slope-intercept form, that y equals mx plus b. In addition to the value for the y-intercept, I also need my slope. So to get slope on a graph, we can trace the graph until we find where it hits the corner of a box, find 2 points on our graph, draw our slope triangle, and then we can use our meaning of slope as rise over run to find our value. So in this case, it's an increasing line, so my slope is positive. Between these 2 points, there's a rise of 2 and a run of 3. So my slope is going to be 2/3. Once I have my value for slope and my value for y-intercept, my m and my b, I can put them into the slope-intercept form and replace m and b with those values. So instead of y equals mx plus b, we're going to put y equals, we're going to replace our slope with the value we found, in this case 2/3, then our x, and then our plus b. In this case, my b was positive 5, so I'm going to put plus 5. If this had been a negative number, we would put a minus, but this one is positive. So we're going to do plus 5. And that right there is my slope-intercept form. And it's, again, called the slope-intercept form because we can easily identify our slope and our y-intercept. Now, the directions here want us to now take this line and rewrite it in standard form. So again, standard form is the format where the x's and the y's are on the same side of the equal sign together, and they're going to equal, the number is going to be all by itself. And the important thing to remember is that a, b, and c should all be integers. So we shouldn't end up with any fractions in our final answer. So we want to take this equation and we want to move it around so that it looks like this, but where A, B, and C are some numbers. So we're going to take this equation and we're going to transform it and rewrite it. So the same line can also be represented. If I take this 2/3 x and I take my x and move it to the other side, I would need to make a 0 pair so that I would have no more x's over here. And if I subtract 2/3 x from the right side of my equal sign, I would have to also subtract 2/3 x from the left side of my equal sign. So this is my 0 pair, so those are no longer there. So those would be canceled. But on this side now, I would have the negative 2/3 x and that y. Since they're not like terms, I can't combine them. But I can write them side by saying I have negative 2/3 x plus y, since that was a positive y. And on this side of my equal sign, those are gone, and I'm still left with that positive 5. I'm getting closer and closer to my goal of standard form because I now have my x and y's on the same side. But the thing is again, this has to be integers, so no fractions. So if you see a fraction anywhere in the problem, we're going to multiply the entire problem by whatever number is in my denominator. And in this problem, the denominator is 3. So we're going to multiply everybody by 3. Now, if you need to grab your calculator, you can do that. You would take negative 2/3 times 3. And if you do that, your calculator should tell you that's negative 2. So we would get negative 2x. We're going to take 3 times y. So when I multiply a number and a variable, they just get stuck together like 3y. And then we're going to put our equal sign, and 5 times 3, that is 15. We're almost done. It's almost in the standard form that we want, but the problem is that this a is negative. So the key to remember is if a is negative, so that first number is negative, we're going to divide everybody by -1. So we'll divide this by -1, that by -1, and also that by -1. And if I divide everybody by -1, 2 negatives will switch to make that positive, which is what we want. A positive divided by a negative would be a negative. It's okay if this guy's negative. You just never want the first one negative. And that would give me -15. And now that my x's and y's are on the same side of the equal sign, it's in my standard form. And again, my value for a is positive, and there's no more fractions in that problem. So you're going to do number 2 just like we did this example. As we continued in this unit, what we saw is that we can write equations of a line given a point and a slope. So if we're going to be using equations given a point and a slope, well, doesn't it make sense to use our point-slope formula? And remember, your point-slope formula is that y minus y1 equals m parentheses x minus x1. And when we're using our point-slope formula, the y1 and the x1 come from my point, and the m is my slope. That is why we call it the point-slope formula. So whenever I'm working with point-slope form, I always say it's y minus blank equals blank parentheses x minus blank. And I'm going to fill in those blanks in that point-slope form with my values from my point and my values from my slope. So as I'm reading this problem here, it says write the equation of the line with a slope of -1/4. So that's going to go where my m should go in my formula, right in front of the parentheses. That's my slope. And then it passes through the point, -8, 1. So remember, every ordered pair is x then y. And this formula is trying to help me out here. It's saying I want my value for y here because I want to go y minus some number. So I'm going to go find the y number that they gave me, in this case, +1. And then over here, I want to do x minus the number. Well, I want the x value that they gave me, which was -8. The only thing we would do to clean up point slope form and leave it as point slope is if we have two negatives back to back like that, we can put a negative times a negative and make this positive. So I can write this in point slope formula cleaned up a little bit by putting the -1/4 and then in parentheses instead of two negatives, make that a positive. And this is called the point slope form because the values with the x and y represent the coordinates of my point, and the number in front represents my slope. Now, that's one way to write this line, but we also know that, again, our slope-intercept form is that y equals mx plus b. So if I say, hey, write this as slope-intercept form, you want to get the y by itself. Notice there's no parentheses. Y is all by itself. So we need to go here and we need to get no parentheses. So we'll use that distributive property. This side's going to stay right now, but we're going to take -1/4 times x. Again, a number times a variable just gets put side by side. And if you have to grab your calculator, -1/4 times 8 would give you a -2. We're going to drop that here as -2. We're getting closer and closer to that slope-intercept form. Now I no longer see parentheses from my point slope form, but the y still isn't by itself. So to finish this up, to get the y by itself, we're going to make that 0 pair. And so the opposite of -1 would be +1. That way I can 0 out that number, and I'll add 1 over there to keep my equation balanced. So then I'm left with just my y equals -1/4 x, and then -2 plus 1 would be that -1. And that is what my slope-intercept form would look like. Now, this question was a big question because it asked me to not just write it in point slope form and slope-intercept form, but it also wanted standard form. So remember, standard form is where our x's and y's are on the same side of the equal sign, and it equals some constant, some number, and there's no fractions. So let's rewrite this guy. So first thing I want to do is get my x and y's together to start looking like this. So I want 0 x's here. So to 0 out my x's, we're going to do the opposite. And if I add 1/4 x to this side, I need to add 1/4 x to that side. Again, they're not like terms, so I can't combine them, but I can put them together. I have 1/4 x and a positive y, so 1/4 x plus y. Those are gone, and I'm left with just that -1. We're getting close to this format. Remember, the problem is that we never want to see fractions. A, B, and C should always be just integers, so no fractions. So if there is a fraction like we see that 1/4, we'll multiply by whatever's at the bottom there. In my denominator is 4, so I'm going to multiply everybody by 4. So 1/4 times 4 is 1, so you can write 1x. 4 times y would be 4y. And then 4 times -1 would be -4. We don't really need that 1, so we can just write this as x plus 4y equals -4. These three equations all represent the same line. They're just different formats representing different things. In this form, I can find my point and my slope. In this format, I can find my slope and the y-coordinate of my y-intercept, my m and my b. And in standard form, I could use that format to find my x and my y-intercepts if I wanted to do that. All right, we're going to look at one last example, and then you're going to finish up these two remaining problems that you can mirror with the example right next to it. The only difference between number 3 up here and number 5 right here is that in number 5, we have 2 points. So I can't write an equation of a line without knowing a slope. right? My slope formula, my point slope form needs a point and a slope. My slope intercept form needs a slope and a y-intercept. So if I give you 2 points, the first thing you're going to do for me is find me that slope. And you can, if you have a graph, count that rise over run. If not, we're going to use our slope formula. So I'm going to go off to the side here and find my slope. So I have my 2 points, 8, -8, and -4, -2. Every point goes x and y, x and y. This is my first x and my first y. That's my second x and my second y. So that's why they're called x1, y1, and x2, y2. When I do my slope formula, I take y2 minus y1. So -2 minus -8. Then at the bottom in my denominator, x2 minus x1, -4 minus 8. Here I have -2 minus -8. That's the same as -2 plus 8. And -2 plus 8 is 6, and then -4 minus 8 is -12, and that fraction can be reduced to -1/2. So now I have my slope. In order to write it in point slope formula, I need a slope, and we just found out that guy is -1/2. I can drop this in here, right where my m would go in my point slope form. But I still need to have x1 and y1 dropped in here. And you can technically pick either of these guys, but this one's already labeled x1 and y1 right there in my problem, so I'm going to grab that. So this is saying y minus my y coordinate. Well, that was -8. This is saying x minus my x coordinate. Well, that was +8.
Office detention will be held in room 119 today. Office detention will be held in room 119.
To finish the point slope form, we're going to take the 2 negatives, and we're going to write that as y plus 8. And then we're going to get that -1/2, and then x minus 8. And that would be my point slope form. If I want to get it in slope intercept form, that's where I want the y by itself. So no parentheses and the y all alone. So we're going to distribute to clear the parentheses to start getting it into that form. The left side stays. So I would have -1/2 x when I multiply those guys. And then a negative times a negative is a positive, and 1/2 of 8 is 4. And if I want the y by itself, again, I need that 0 pair. That would cancel. So I would get y equals -1/2 x minus 4. And that is what my slope intercept form for that line would look like. And then lastly, to get this guy in standard form, I want my x's and y's together. So I want to get it from slope intercept over to standard, I want to zero out the x's here. So if I have a -1/2 x, to zero it out, I would add 1/2 x. To keep it balanced, I would add 1/2 x on this side. Again, these are not like terms, so I can't combine them, but I can add them. 1/2 x plus y, those are gone, equals -4. Standard form, remember, A, B, and C cannot have fractions. If we see a fraction, we multiply everybody by whatever number is at the bottom of our fraction. In our denominator was that 2. So we're going to multiply everybody by 2. And 1/2 times 2 would give me 1x. Y times 2 would give me positive 2y. -4 times 2 is -8. And again, you don't have to write that one. So in standard form, our equation would look like just x plus 2y equals -8. 3 equations all representing the same line. Again, each one gives me their own characteristics. Point slope tells me my slope and the coordinates of a point. Slope intercept tells me my slope and the y coordinate of my y-intercept. And standard form we use to find x and y intercepts if we wanted them. All right, so your goal now is to go and finish numbers 2, 4, and 6, and let me know if you have any questions.